Today's lesson's on point-slope form of a line. There are three forms of lines that we talked about. We got slope-intercept form, which was lesson 2-3. And now today we got point-slope form, which in order to write an equation, you're going to want a point and a slope. For slope-intercept form, you want a slope and a y-intercept. So here we got point and a slope. You can plug it into this form, y minus y sub 1 equals m, which is your slope, times the quantity, x minus x sub 1. Well, I ask you if that looks familiar. And the reason I say it looks familiar is because you see y minus y and you see an x minus x. And for me, that reminds me of the slope formula, which we think of as y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Well, if you didn't think of this as y sub 2 minus y sub 1 or x sub 2 minus x 1, instead you thought of it just as y minus y1 and x minus x1, you can see the point-slope form up above from this. I can multiply over the x minus x sub 1 and you have point-slope form. You have slope times x minus f sub x sub 1 equals y minus y sub 1. That's your point-slope form. So that's where you get point-slope form, just based off the slope formula. How do you use it? Well, if you have a point and you have a slope, just plug them into their proper spots. The key here is to realize that this point is x1 sub y1. It's not xy, it's x1 sub y1. When you write a linear equation, more times than not, you've got a plain old y and a plain old x left in your equation when you're done. And that's what we need here. That's what these two things are right here. There's my plain old x, there's my plain old y. A couple of times you don't have an x. Well, if I don't have an x, I have y equals something. And that is what kind of line? That's a horizontal line. Or if I don't have a y, I have x equals something. That would be a vertical line. Okay, so when we plug in our point right here, they go in for y1. So I'm going to have minus, and then I plug in my negative 8. That's y1. So it's y minus negative 8 on the left, which of course turns into y plus 8. On the right, I plug in my m, which is negative 2/3. And then I take x, leave that there, and subtract the x sub 1, which is 12. This, technically, is an equation of a line in point-slope form. So here, I didn't specify to write it in a different form. So this right here is a good answer. Now, in future problems here, what we'll do is we'll end up distributing the negative 2/3, and then you could bring over the negative 8. And if you do that, you will put it in slope-intercept form. But let's not do that on this problem. Let's do another one just like this. Okay, so my second problem here, I don't have slope, but I have 2 points. So we're going to actually have to find slope first, and then we can plug it in with either one of those 2 points. So finding slope, we subtract the y's. I, in this case, would start with the 10 and subtract the negative 2, because that'll give me a positive on top, and I like to keep it positive. 10 plus 2 is 12. And then on the bottom, I'd have to go with the negative 2 minus 6. I have to start with that negative 2. That gives me a negative 8. Well, I can reduce that. 4 goes into it, gives me negative 3/2. So I ended up with a negative on the bottom, but I had no choice. Because I started with a 10 on top, I had to start with a negative 2 on the bottom. So now I've got the slope, and I could use, what I'm going to show you here is I can use either one of these 2 points, and I'll get the same answer. And that's why I said prove they are equations of the same line. So let's say I use the 6, negative 2. If I use the 6, negative 2, I'm going to have y minus y1, which is negative 2. I put a comma there, excuse me, equals the slope, which is negative 3/2, times x minus the x1 coordinate, which is 6. Now over here, this turns into y plus 2 equals, I'm going to distribute the negative 3 halves. So I'm going to get negative 3 halves x. A negative times a negative is positive. And we could do 3 times 8 is, or 6 is 18, divided by 2 is 9. Or I could do 6 divided by 2 is 3, and 3 times 3 is 9. Either way, I get a 9. And I bring the 2 over, subtract it over. And that gives me plus 7. This is what that equation is in slope-intercept form. If I didn't specify slope-intercept form, I just said point-slope form, this right here would be good, as long as you change that to plus plus. Don't change, leave it 1 y minus negative 2, change to y plus 2. Well, what if somebody decided to use the other point? What if they decided, let's use the negative 2, 10. Well, if I was going to use negative 2, 10, I need to go y minus y1, which is 10, equals the slope, which is negative 3 halves, times the quantity x minus the x-coordinate, which is negative 2. Now the minus negative over here turns into one big plus. And my new equation, if I distribute, would be y minus 10 equals negative 3 halves x. Negative times a positive is negative, so we can go minus, or we can go plus negative. And 3 halves times 2 is 3. Run in slope-intercept form so we can see that, in fact, these equations are the same. We would add 10 over. And if I add 10 to negative 3, I get plus 7. And I've just shown that they were, in fact, the exact same equation. Well, the third and final form we'll discuss with a linear equation is standard form. Standard form means you're going to get x and y on the same side. I want the x term first. And we're going to make it so that the numbers in front, or the coefficients, a, b, c, are integers. I also want a to be positive. A has to be greater than or equal to 0. So non-negative. Number 3, write this in standard form with integer coefficients. Well, a couple ways to start it. I'm sure most of you would say, you know what, let's bring over the 3/4 x and make it a negative 3/4 x plus y equals negative 2/3. Now, I said that the first term has to be positive or non-negative. This is a negative, so you can take care of that now, you can take care of it later. Let's take care of it now. Instead of having a negative front, I want it to be positive. Well, if I change the first term to a positive, then I have to change all the other terms. So y turns into negative y, negative 2/3 turns into 2/3. Now my final big move here is to get rid of the fractions, because I want integer coefficients, and 3/4 is not an integer. The way I would suggest doing that is to multiply each and every term by the least common denominator. Now the denominators are 4 and 3. What's a common multiple of 4 and 3? 12. So we're going to take and multiply everything by 12. 12 times 3/4. Well, 12 times 3/4 is the same thing as 12 divided by 4, which is 3. 3 times 3 is 9, so 9x. Times negative y, negative 12y. Not much thought there. And finally, 12 times 2/3. 12 divided by 3 is 4. 4 times 2 is 8. This is a standard form equation of the line above. It's a standard form equation where a is 9, b is negative 12, c is 8. And here I want a point slope form. Hopefully recognize this and say, okay, I know that the slope of this would be negative 2, and it goes through some point. What point? Well, it's got x minus 5, so x1 is 5. You might think it's negative 5, but really it's just 5 because we're subtracting 5. We're not subtracting negative 5. And another one's 4. That's just a quick review of what this point slope form means. It means I have a line that goes through negative, or has a slope of -2, goes through 5, 4. Now, I don't really need that to come in standard form. To write this in standard form, I'm just going to distribute. Bring the x over to the left, so minus 2x turns into plus 2x. And bring the 4, the minus 4, bring that over to the right by adding 4. There's my standard form equation with integer coefficients and a being greater than or equal to 0. Okay, word problem. Plumber works on a job for 12 hours, gets paid $600. Works on another job, gets paid $420 for 8 hours of work. Write an equation that represents how much he gets paid based on hours worked. So again, we had a problem similar to this in the last section, and what I did is said, you know, if you get stuck, think of a graph and think what would go where. I say dollars are based on hours worked, so the base is hours. And what's based on that? Dollars. So my y-axis is actually D, my x-axis would be H, hours. Now this makes sense. Generally your time goes on the x-axis. Your independent variable goes on the x, dependent on the y. Dollars depends on hours. I get paid based on how much I work. Okay. Now, if I was going to graph this, I would think that you got 12 hours and $600, so I would think of that at some point, you know, maybe 12, and then I put a 600 here somewhere, and it's a point, that's what it is. So 12 comma 600 is a point. And then $420 for 8 hours, well, that would be another point in here. You know, let's say 8 and 420. That would be another point. And I'm trying to figure out what's the equation of the line, or in this case it'd be a ray because you can't work negative hours. What's the equation of that that represents any amount of time worked? So what I gave you is 2 points. What will happen is people will get these accidentally reversed, put 600 comma 12, 400, 420 comma 8. You got to be careful with that. Think about what your x and y need to be. Now you've got 2 points. Go through the same work we did before. Find the slope. Subtract the y's, subtract the x's. Subtract the y's, I get 180. Subtract the x's, I get 4. Divide those two, I get 45. Slope's 45. What does that mean? It means every hour it goes up 45. Every hour goes up 45. This plumber's getting paid $45 an hour. Now I want to write an equation. Well, I can put in point slope form. I could use either one of the 2 points. Let's use 8, 420. If I use 8, 420, it'd be y minus 420 equals the slope, which is 45, times x minus 8. There's an equation in point slope form. We could continue on and turn into slope intercept form. Distribute the 45. 45 times 8. 40 times 8 is 320. 5 times 8 is 40. 320 plus 40, 360. Add over the 420. Add over the 420. You've got slope intercept form. What's significant about this number at the end, the 60? Well, that's your y-intercept. And what does the y-intercept in this case mean? It means when this plumber works 0 hours, they get $60. So they get $60 just for showing up. I did have a follow-up question. I want to know how much they get paid for a 30-hour job. Well, you know, I use y and x here. Really, y was d and x was h. And 30 is my hour, so I'm just going to plug in a 30. So for 30 hours, you have 45 times 30 plus the 60 for just showing up. 3 times 40 is 130. Let's see, 3 times 45 would be 120 plus 15, 135. So it's 135 with a 0 because it's 30, not a 3. Add 60. This plumber get $1,410. Linear equations are in standard form. It's often easier to graph them using the x and y intercepts of the graph. Simply plug in 0 for y to find the x-intercept, and plug in 0 for x to find the y-intercept. So here is a standard form equation. I want you to think of a table where you're plugging in 0 for x, 0 for y. If I plug in 0 for x right here, I get 3 times 0. So what happens is this really just gets crossed out. If I solve that, I get y equals -3. Now let's go back and let's plug in 0 for y. Well, that just crosses that out. And I get x equals 5. So a lot of times it ends up being some really quick mental math to get your intercepts. So x-intercepts 5, 0, that's right here, that's where it crosses the x. 0, -3, right here. Take a ruler, whatever straight edge here, try to hit the dots. I missed. You get the idea. And I'll slide it down a little bit, I guess that could make it better. Okay, there we go. So there's the equation, or the graph of that line that had a standard form equation. Practice again, plug in zeros. Plug in 0 for x, that basically crosses that out. -18 divided by -3 is 6. That's my y-intercept. Start over. Plug in y is 0. That basically crosses that out. 3 times 0 is 0. -18 divided by -2 is 9. 4, 5, 6, 7, 8, 9. Draw a nice line through there, or cheat a little bit. Use a smart board so you get a better looking line. Next problem. Okay, parallel and perpendicular lines. These are special. You need to be aware of their slopes. Parallel lines have same slopes. That way they won't cross. If you have the same slope, you can't cross. And we talked about that earlier, where I said, I have so much money. Say I have $5 and I save 2 a day. And let's say Joe is 2 in the hole and he saves 2 a day. When will we be the same? We won't. We gain at the same rate. We start at a different amount, gain at the same rate. So we have same slopes, same rates. Perpendicular lines have opposite, or you could say negative, reciprocal slopes. So you could flip it over, switch the sign, you've got yourself a perpendicular slope. So we're going to do one each of these, I believe. So I've got a equational line that's parallel to 5x minus 2y equals 8. So all I need for this equation is its slope. I don't need to graph it or anything like that. If I wanted to graph it, here would be a sketch. I could see the x-intercept would be 8/5. So something right in there. The y-intercept would be -4. Something like that. That would be the given graph. Okay? But I don't need that graph. What I need is a slope. So let's get the y alone. Bring over the 5x. Let's divide by -2. Okay? And I see the slope. The slope is 5/2. So the slope of my graph that I just did is 5/2. So from my y-intercept to -4, if I go 1, 2, 3, 4, 5, up, 2 over, I should be on the line. Well, I don't care about that. What I care about is that parallel lines have the same slope. So I'm going to use a slope of 5/2 along with the point 15, -4. Now I didn't specify what kind of equation I want here, so I'm just going to do point slope real quickly. Be aware that you might have to change that to slope intercept and then change that to standard form, but let's just put it in point slope form. So we need y minus the y, which is -4, equals the slope, 5/2 times x minus the x, which is 15. My x1 is 15, my y1 was -4. You can leave it just like this except for change that to a plus. That's a good equation for my parallel, for a parallel line to the one that is up here already. Perpendicular line. Perpendicular line, here I got y equals negative 3/4 x minus 1 point, I put the 1.043 just to show you that's goofy, and that really doesn't matter. All I need is that the slope of this line is negative 3/4. If the slope of that line is negative 3/4, then the perpendicular slope, that's that upside down t for perpendicular, would have to be, flip it over, change the sign, 4/3. Right, so I used the given equation to get its slope. I then flipped it, turned its sign to get the 4/3 for a perpendicular line. Plug that in with my point in a point slope form. It would look like this: y minus y1, which is 5, equals the slope, 4/3, times x minus x1, which is negative 9. And you could leave this in point slope form, changing that to x plus 9 in the parentheses, or you could distribute and get the y alone if we needed to find the y-intercept, or if I just simply asked for the answer in slope-intercept form. Guess I can remind you of that quickly here. It'd be y minus 5 equals 4/3 x plus 9 divided by 3 is 3. Times 4 is 12. Add the 5 plus 17. So this is point slope form. This is slope intercept form. Standard form would require me to bring over the x, switch the sign because I want x to be positive. So let's switch all those signs, and then get rid of the fractions by multiplying everything by 3, the common denominator. That would cancel this 3 out. It would make y 3y, and then negative 17 times 3 is negative 51. Those are your 3 forms: point slope, slope intercept, and standard form. Thanks for watching. Have a great day.